Hello students. So welcome to AIMS India's online classes. Today from physics subject, measurements topic we are going to continue. So before going to the concept, first observe the two short videos children here. Here in the first picture, the ship is sinking into the water and all the people who are on the ship, they are screaming. Means they are shouting loudly to make them, to protect them. So in the first picture, ship is sinking into the sea, whereas in the second picture, the petals of the rose flower are floating on the water. The petals of the rose flower are floating on the water. So in today's video, we are going to know about the reason behind this sinking and floating. The scientific reason behind this sinking and floating in this video we are going to learn. So floating and sinking. So why do bodies, these eye children, why do some bodies sink or some bodies float in liquids? What is the reason? That is also this floating and sinking we can mainly observe in liquids. So why does it happen so? That we have to answer. So if you observe these pictures, as we have seen in these pictures, if a piece of cork is placed in water, it rises and floats on the surface of the water. Whereas if a piece of stone or piece of iron kept in water, it sinks down in the water. So however, the Bioend force acts on the both cork and stone is same. Then why does the cork float and why does the stone or iron sink? If you keep any object in the water, some objects may go deep down into the liquid like this. Some objects may float underneath the water like this. Some objects may float half portion above, half portion below like this. But whenever any object is placed in water, or suppose if you take a bucket of water, and if you try to push a football into the water, so what you will experience? You will experience that water is pushing the football upwards. Water is pushing the football upwards. While you are trying to push the ball into the water, you experience such that the water is trying to push the football upwards. This upward force is called Bioend force. The upward force shown by the liquids is called Bioend force. Though the Bioend force is same in all the objects, cork, stone or iron, but still why the cork float, why the stone sink down? We have to know the reason behind that. So when a body is immersed in a liquid, mainly two forces act on it. Two forces act on the body. One is weight of the body, say W1, acting downwards, and the Bioend force of the body, W2, shown by the water, acting upwards. So whenever a body is kept inside water, two forces acts on it. W1, which acts in downward direction because of gravity. W2, Bioend force because of water. These two forces will act on any body which kept in water. So the body always will move in the direction of the resultant of these two opposite forces. This is W1, this is W2. What is the value of W1? What is the value of W2? Which one is greater? What is the resultant? What is the W weight? What is the resultant force? Because of these two forces, in that resultant force direction, the body will always move. So we have mainly three conditions basing on this W1 and W2. So first one is the weight of body is greater than the Bioend force. Weight of the body means W1. W1 is greater than W2. Means downward force is greater than upward force. As downward force is more than upward force, it will come down, like in first diagram. So why it is coming down? W1 is greater than W2. Downward weight is more than upward force, Bioend force. So that's why the body is completely sinking down, coming down. That is first case. Whereas second case, the weight of the body is equal to Bioend force. Means downward force equal to Bioend force. In this condition, the body will just float below the surface of liquid. Below the surface of liquid. Means just float below the surface of liquid. It won't go above the surface, just float below the surface of liquid. In what case? If W1 equals to W2. In this case, suppose you take a glass full of water, and if you throw a block into the glass such that its weight W1 equals to upward force W2, satisfying this condition. So then what happens means, as the glass is full of water, if you keep one block into the glass of water, how much volume of block went into the water, same amount of water will be displaced out. So because we are sending one object into the water, so some water will be displaced outside. In this case, the displaced water volume and the object which is kept inside, that volume, both will be equal. Or not volume, weight. The weight of the displaced fluid equals to weight of the body. Weight of the displaced fluid equals to weight of the body. Means how much weight you have kept inside, that much weight will be displaced outside, and it will float exactly below the water level. That is second case. Next, third case. So weight of the body is less than Bioend force. W1 is less than Bioend force. Downward force is less than upward force. So then what happens? So upward force, upthrust is more than the weight of the body. Hence, the body will float partially immersed in the liquid. Means partially immersed. It is completely immersed, these two cases. But here, only some amount of the body will go into the water. Remaining amount of the body will float above the surface of the water. In what condition? If W1 is less than W2. Okay. Like this, we have three possible conditions regarding this floating and sinking. So when weight of the body W1 is greater than W2, weight of the body is greater than Bioend force, the body completely sinks down. When weight of the body equals to Bioend force, the body just floats below the surface of water. When weight of the body is less than Bioend force, the body will float partially immersed. Means some portion of body some portion of the body will be underwater, some portion of the body will be above the water. That is called partially immersed. In these three cases, any one case may be possible. Next. Next we have, children, principle of flotation. Principle of flotation. So by the three conditions of floating and sinking of a body, we conclude that a body will float in a liquid if the weight of the liquid displaced by it is equal to its own weight. This is called principle of flotation. Principle of flotation means, as in the second case, how much amount of weight of body is kept inside water, same amount of water is displaced. So this is taken as principle of flotation. This condition is taken as principle of flotation. Okay. Suppose a body of volume V is floating in a liquid of density D. In yesterday's class we have told density means mass by volume, mass per unit volume. So if a body of volume V is floating in a liquid of density D, let the volume of displaced liquid is small v and density of the body capital D, because if we kept a body of volume V, if we kept body of if we keep body of volume V into the liquid, so same amount of liquid will be displaced outside. So some amount of liquid will be displaced outside. Let it be small v, and density of body be capital D. So then mass of the body, according to this formula, density equal to mass by volume. What is mass? Density into volume. So mass of the body equal to volume of the body into density of the body. Volume of the body capital V, density of the body capital D. Weight of the body, how much? Weight means W equals to mz. Mass into gravity. Mass into gravity means V into D into Z. So this is mass of the body, this is weight of the body. So mass of the displaced liquid. Mass of the displaced liquid, we are taking it as small v. Because of keeping this body inside, how much amount of volume is displaced, that we are taking as small v. This we are taking as capital V. Okay. So mass of displaced liquid, volume into density. So volume of displaced liquid small v, volume of density of displaced liquid small d. So weight of displaced liquid, mass into gravity, V into D into G, all small letters. Now according to principle of flotation, so weight of the body, how much weight of the body we have kept inside the water, that much weight of liquid will be displaced. These two are equal. Means capital V into capital D into small g equals to small v into small d into small g. So Gg gets cancelled. So volume of body, density of body equal to volume of displaced liquid, density of displaced liquid. Or this V will come down. This D will come down. Capital V by small v equal to small d by capital D. Or volume of floating body. This capital V means volume of floating body by small v means volume of displaced liquid. This ratio equals to small d means density of liquid by capital D means density of body. Body here it will be in the numerator, it will be in the denominator. Displaced liquid here in denominator, here numerator. So from principle of flotation, we can finally come to this conclusion. Okay. So this is the condition for floating of a body. Condition for floating of a body. So here, floating means we have to take this case. So this one, partially immersed, means we have to consider this case. Total body sink means we have to consider first case. First case is for if the body is totally sink, so then first case. If body is floating, second case. Body is partially immersed, then third case. So as we are in the principle of flotation, we have taken second case here. Next, some applications of principle of flotation. Applications of principle of flotation. So why ships keep afloat while a nail of iron sinks? So if we throw iron into the sea, the iron will sink down, but the ship won't sink down. It will be floating in the water. What is the difference? What is the difference that they are asking? So here, the volume of displaced seawater by a ship is more because the base of ship is larger compared to the nail, and hence buoyant force increases and becomes equal to the weight of the ship. Thus, a ship floats in seawater. So here, actually, why the ship is floating in the water means the base of the ship is more. The base of the ship is more. So that's why, because the base of ship is more, it will displace while traveling forward or while traveling backward. It will displace more amount of liquid sidewards. More amount of liquid sidewards, so that the upthrust will become equal to the weight of the ship. The ship is designed in such a way. The ship is designed, specially designed in such a way, such that base of ship is more, amount of displaced liquid is more, amount of displaced liquid is more, such that the upthrust will become here. The buoyant force. Why we are making the base of the ship larger? To increase the buoyant force, and becomes equal to the weight of the ship. So that's the ship floats in seawater. So, but whereas in the case of nail, because the tip, the end portion of nail is very small, so the amount of displaced liquid is small in the case of nail. So upthrust will be less, weight of the nail will be more, and that's why it will sink into the water. So the ship is specially designed. So that's why its base will be having more area to have for having more buoyant force. Okay, that is one kind of application. So iceberg also is there. Let's see in this example. So you can observe here, children. So on the above water level, we can see a huge ice block here, which is floating above the water level. Some part is below the water level, some part is above the water level. And here one shark is flying between the, moving between the icebergs. So this phenomena of iceberg is also an application of this principles of flotation, children. So the base, here also the base is more, the base of the iceberg is more, so that's why upthrust is upthrust increased and becomes equal to the weight of the liquid, so that's why it is floating. So we can compare the iceberg illusion with success. So actually what people see means which is above the water level, this success only they can see. But what people don't see, which are main reason for success: dedication, hard work, good habits, disappointment, sacrifice, failure, persistence. These are all which are the reasons for the success. Nobody will see the reasons, just they will see the success. So that's why you may get failure. You should not get disappointed. So you have to try for success. So ultimately, people will recognize your success. Success is an iceberg, children, in this example. Okay. So icebergs float in seawater. So iceberg means large pieces of blocks of ice floating in seawater are called icebergs. So the density of ice is 0.9 gram per centimeter cube. A little less than density of seawater, which is 1.02 gram per centimeter cube. Means almost they are equal. So that's why iceberg is floating in seawater. Iceberg is floating in seawater. Actually, in terms of density also we can compare. If density is more, it will sink. It will sink into the liquid. If density is less, it will float. Or if here the density is somewhat less compared to the density of seawater. So that's why it is floating. Next, children, hydrometer. So here, children, hydrometer, it's a device based on the principle of flotation, children, to read the density of liquid. To find the density of liquid based on principle of flotation, scientists have designed a machine called hydrometer. So some special hydrometers are designed to test whether a battery is fully charged or whether milk is pure or not. Even the purity of milk also we can check with the help of hydrometer. Even liquid batteries, we can check whether they are fully charged or not with the help of hydrometer. So here hydrometer, children, hydrometer means, so in one kind of container, one liquid will be there. So here one stem with scale, one scale having some stem is kept inside the liquid, which is having some index points here, 0.6, 0.7, 0.8, 0.9, like that. So it may fall down. This scale may fall down, or this tube may fall down. To avoid that, here they have kept some weight. Here they have kept some weight to keep the hydrometer upright, straight. So here a tube having scale downside, having one bulb calibrated with scale, is kept inside some liquid. This kind of arrangement is called hydrometer. When it is kept in the liquid, it will give the reading of density. It will give the density of that particular liquid. So the complete working and functioning of this hydrometer you can learn later, children. So here, what is hydrometer means? Its structure is like a tube fitted with the bulb at one end. The tube will be having scale marked on the stem. Bulb will be having some weight to make it stand straight. When we keep this hydrometer in any liquid, the index point will be there. It will rise. It will rise up or lower. It will rise down, such that where it stops, that will be the density of that particular liquid in which we are keeping the hydrometer. Okay, children. Okay, children. That's all for today, children. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you, children. Have a good day.